Okay, let's have a look at the Raspberry Pi onboard computer system. Let's turn it on, and we can start by having a look at the LCD screen. The LCD screen displays all the important information. And we start by getting this boot up screen. And then we have 3 different screens that it is circulating between. We also have 2 USB ports here and there. Now it waits a little bit for the GPS to find a position and stuff. And it takes a little while for the system to start. But then we get the first screen. Now this is the most important screen. This is the GPS screen. We have a date and the current time, latitude and longitude, our current speed, and our current course over ground. Now this being the most important screen, it is shown for 1 minute. And then it circulates through the other screens, and the 2 other screens are shown for 30 seconds each. Here we have the second screen with the digital clinometer at 0 degrees. Heading, which is a digital compass, log, which is total distance traveled, and wind. I don't have a wind sensor yet, so this is just a placeholder at the moment. But I hope to implement a wind sensor at some later point. Now we have the third and final screen with the barometric pressure, inside the temperature, the current outside temperature, and lastly we have water temperature. So this screen is also shown for 30 seconds, and then it starts on the first screen again, and it circles around. Yeah. Okay. Yeah, here we have the control panel for the amplifier, and the actual Raspberry Pi and the amplifier are mounted behind this panel inside the wall here, inside the waterproof, inside 2 separate waterproof junction boxes. Let's unscrew this panel and have a look behind here at the junction boxes. This is the computer, and this is the amplifier. Now let's have a look at MAX 9744 20 watt stereo amplifier board. The control panel is mounted here, and we have an on and off switch, volume adjustment, input selector switch. We can choose between having input from the Raspberry Pi or from aux in, which takes input from this 3.5mm jack input. Let's try to turn it on, and we'll set the input to the onboard computer system.
The air was dark above Gravesend. Farther back still it seemed condensed into a mournful
Or if we want, we could
motionless over the biggest and greatest town on earth.
plug in this 3.5mm jack
Then in the darkness, my friend
and
Marla
switch over
spoke.
to aux. Now 20 watt might not seem like much, but it can actually be quite loud, and it's at least enough for my use. I can show you the speakers. Okay, I have some GVC speakers. One of them is mounted over there, and the other one is mounted up there. Now let's have a look at the 10 degrees of freedom sensor. It's a 3-in-1 LSM 303 accelerometer and magnetic sensor, and also L3GD20 gyroscopic sensor, and BMP 180 barometric pressure and temperature sensor. It's mounted all the way at the bow, all the way up there. There it is, inside this waterproof junction box. So the important thing when you mount a magnetic sensor is to put it far away from any magnetic disturbance. Up here I'm getting really good results because there's no metal or electric equipment in the area that could cause some disturbance. Let's head back here. Up here we have the 4G Wi-Fi router. It's a Huawei B593S, and it runs on 12 volt, so you can connect the router directly to a 12 volt supply, which is quite nice. Alright, let's head outside. Okay. Here we have the 150 watt solar panel. Down here we have the camera. And down here we have the GPS unit. Now here we have the 10-inch touchscreen. So I've placed an order for a adjustable, like a deck mount for mounting the screen. So I'm gonna have it mounted like this, but I haven't received the mount yet. Here we have an on and off switch, which is useful if you want to run the system in like a low power consumption mode. You can turn off the screen. The system uses about the Raspberry Pi and GPS and all that. It uses about 3 watts or 0.25 amps without the screen, but with the screen it uses about 6 watts or 0.5 amps, so the difference is quite big. So it can be smart to turn this off during the night or something if you're without shore power. One big problem with the screen is the reflection, but I hope to fix that by adding like some anti-reflective coating on here. Alright, let's turn on the touch screen. Okay, starting from the top we have the menu, then we have the taskbar, but since we don't have any tasks open at the moment, we can't see it. Here we have all the information. We have a clinometer, compass heading, log, which shows total distance traveled, wind direction and speed, barometric pressure, temp inside, outside, and water temp. And then down at the bottom here we have a GPS status panel with fix that shows if we have a GPS 3D fix or not, our current date and time, latitude, longitude, our current speed in knots, and course. So to right click on the touchpad, we just click for a bit longer than usual. If you click for 250 milliseconds, it counts as a right click, like this. Oh, there we see the right click menu on the desktop. Now let's have a look at this menu up here. First we have the location history. So the system automatically logs our location when the system starts, and also once every full hour, but only if we have moved a minimum of 50 meters since the last entry in the location history. So at the moment we only have one entry in the database, but after you move a bit you can see all the different places you've been. So at the moment, both the location history and also the weather history is very simple. But in the future I plan to make some interface, like a graphical interface, where you can view your location history and the weather history in a more presentable way. So now we can open the weather history. Here are all the entries to the database. We can also see some things like records, like the highest recorded value for temperature and the lowest recorded value for temperature and things like that. The weather data is automatically logged once every full hour. Now let's look at the taskbar, because now that we have some tasks open, the taskbar is visible. So as you can see, the different tasks are shown here. We can left click on the inactive tasks to switch to it. You can left click the active task to minimize it. Now we have minimized all the tasks. Or we can right click the task to close it, like this. Okay, the next item here is used to launch OpenCPN chart plotter. Oh, here we can see our current position. OpenCPN is a very nice, very good chart plotter, and it's completely free and open source, so that's nice. We can also use the Watchdog plugin to set up different kinds of alarms, like an alarm if we are about to collide into land, or if we have AIS installed, we can put up AIS alarms, or like this alarm that I have set up, it's an anchor alarm. We can test this alarm by running the test like this. Here you can hear the alarm sound for the system, and also we have a buzzer installed, so if the speakers are not connected you can still hear the alarms. Let's do it again.
Смотри экран. Смотри экран. Смотри экран.
Okay. Now let's zoom out a bit. And then we can have a look at the climatology plugin, which is a really nice plugin. It takes a bit of time to start, so it has a lot of data to load. At the moment I have some CM93 charts loaded. I have charts for the whole world. Okay, here is the climatology plugin. Let's right click this window to resize it like so. Okay, now we can enable the wind display on the climatology like this. Here we can see this is just like a pilot chart. We can see the prevailing or the normal statistical wind conditions for certain times of the year. Like now we are on April the 2nd, but we can select whatever we want. So this is of course very useful if you plan to make some passages. You can also see the normal or the prevailing currents. But this, yeah, like this are the currents and stuff. Okay, let's close the climatology window and let's close OpenCPN. Oh, I plan to make a theme for OpenCPN that fits a bit better with the theme and colors of the rest of the system. So I will make some custom icons and stuff and colors for all the lighthouses and all the things like that. Yeah, I'm thinking about making like something like this. Okay, let's close OpenCPN. Next we can move on to the weather data visualizer that can open grid files. It's a program called something like set-igrib. I don't know how to pronounce it. I don't know how to pronounce it properly, but it's spelled like this. So here we have weather data. We can move around the map with these buttons, or zoom in and out with these buttons. So let's download some weather data for the Atlantic. Then we select the area we want to download. Press the download button. And here we can choose what kind of data we want to have included. At the moment I just have a very simple minimal download. To have a smaller download file size, we only have wind information. So let's download this. And then we save the grib file in our grib folder, so we can view it later even without internet connection. This is the current weather situation in the Atlantic Ocean. And here you can see, so this yellow is about 10 meters per second, and this is more like a gale, this orange, and this is calm, like 0 meters per second. Okay, let's close this application. And we can move on to the file browser. So this is our home folder. We have the apps folder with some applications, camera folder with all the photos from the camera. So the camera automatically takes a picture once every hour, and I'm planning to make some like time-lapse videos and stuff from these photos. Now we can look at the latest photo. So this is how it looks. Let's go back. Charts. Here we have our charts. Databases. Here are the 3 different databases. The Onboard Computer System database, which stores all the real-time data, and the weather database, which stores the weather history, and location database for the location history. Documents. Here we have our document collection with some manuals for all the, like for the outboard engine. If we need to do some repairs on the engine. We also have a collection of maritime documents like harbor guides and pilot charts and things like that. And this is very handy, the sailing directions en route. Let's change the view so we can view the full text. We go to view and let's see. Here, let's select the detailed list view. Okay. Let's open. We can look at the VHF channel map to see the VHF channel map, what channels to tune in to on different locations. Or we could open this sailing directions en route. Let's open the one for Japan. So here we have the sailing directions for Japan with all the lots of useful information. So you saw when I opened it, it started down here. That's because I have opened this before, and the PDF reader remembers the page you were at last time, and it opens it at the same page. Let's close it. Go back to our home folder. We can change the view to normal view. You can also save a view for a specific folder. I'm going to do that later for the documents folder, so I don't have to change the view every time to read the full file name. Grib, here's our grib files. Music, here we can put some music. Radio, here I have saved some internet radio stations. And scripts, here we have our scripts. So to do some things on the system, it's a bit more simplified to have and put it to a script than to have to type the commands all the time. So the backup script, the backup full script runs takes all the files in the home folder and takes a backup of it and puts it into a compressed folder, a compressed file. The backup does the same thing, but it excludes the charts folder and also the documents folder and also the music folder to run a quick backup without making the file so large. So once in a while I run the backup full, and this I can run more often. Screenshot takes a screenshot. Update firmware runs the Raspberry Pi firmware updater. This is to update the system, update the packages. Update server updates the takes a backup of the databases and also the latest webcam photo and puts it on a web server, so we can display data from the system and also webcam on a website. And this is run automatically every hour, and this script is for taking a webcam photo. This one is also run automatically every hour. Okay, let's close the file browser. Now we can have a look at the on-screen keyboard. So to show the on-screen keyboard, we click the keyboard button. And if we right-click the keyboard button, we can hide the keyboard like this. So let's test it out. We can open this and open a terminal. We can type something. Okay, let's hide it and close the terminal. And this is the off button. If we press it, we can shut off the system, or if we right click it, we can do a reboot like this. So you can see the booting time for the system. It's quite fast or acceptable. Takes a bit of time for the GPS to start, but yeah, now it's up and running. Okay, let's look at the right-click menu on the desktop. Here we can launch the terminal, launch the file browser. We have a list of all the apps, which is OpenCPN, the Grib file viewer, JTides for viewing tidal information for the whole world. I haven't used this app much yet myself, so I don't know how good it is, but yeah, this is how it looks like anyway. At the moment we see the tidal information for Hamburg in Germany at different hours of the day, and this is the current situation. Okay, let's close this one. Alright, what's next? Okay, here we have a Foxtrot GPS for viewing street maps. So if you arrive in a new port or something and you don't know your surroundings, you can check out how it looks. So this is OpenStreetMap, which is quite good. We also have some other ones like satellite view or Google Maps. We can press this button to center the view on our GPS location. Alright, let's exit Foxtrot GPS. Then we have the CMUS music player. And it automatically starts playing the last song, or in this case radio station we were playing. So here we have some radio stations. Now we're tuned into the BBC.
Azerbaijan said one of its helicopters had been shot down. Russia has called for an immediate ceasefire. Foreign Ministry spokeswoman is Maria
Alright,
Zarakova.
let's hide the keyboard.
We're urging the sides to show restraint, to immediately renounce
Then we have the
Russia has already started
Poisonous
the co-chairs of the OSCE
Super Nintendo emulator.
to prevent an escalation of the conflict.
We'll look at that one later.
About half an hour. Flights from Brussels
Here we can run
on Sunday, but they
different
were
scripts
operating fully until
that we
July.
saw earlier in the script folder.
12 days ago. Only 3 flights are scheduled on Sunday.
Here we have some tools like the network monitor. It's the Slurm network monitor, where we can see the statistics and stuff of our downloads and uploads.
The bodies of soldiers, officers, and pro-government militia fighters were found in the mass grave.
And we have the process monitor, the H-top process monitor, where we can see all our running processes and our current memory situation and CPU usage. Let's close that one. And lastly we have Wi-Fi settings, which is the wicked curses Wi-Fi settings. As you can see, we are connected to the wireless network Console Cowboys in cyberspace at the moment on our static IP. Let's close that one. We can close CMUS, and I'll show you the Super Nintendo emulator. Then we first need to plug in the Super Nintendo controller. Here we have a RetroLink Super Nintendo USB controller. We'll plug that into the Onboard Computer System, like so. And then we'll launch the Super Nintendo emulator. Alright. Let's right click on the desktop, select games, and then we select the Poisonous. Now here we have the ROM selector. We we can control this by using the SNES controller. We'll select the room and press the start button. Alright, let's press select to exit. Then we can press select again to exit the application. Alright, let's turn off the touch screen. We'll head back inside. And we can have a look at the laptop. We'll go to empty workspace. And the Onboard Computer System shares its NMEA data over the local Wi-Fi. So if we go here to this on the laptop and run OpenCPN, we should be able to get position data, GPS position data from the wirelessly from the Raspberry Pi, which we are doing now. So that works. Okay, let's close OpenCPN.